We're now ready for problem 12 on this midterm review assignment. We're going to now start figuring out some derivatives. So we're given the function g of t and we're asked to find the derivative. I'm going to use the power rule, but in order to use the power rule, I need the variables in the numerator up in the top. So if I have t cubed on the bottom, I can move it to the top by making it t to the minus 3. So now the derivative using the power rule, the 8 is a coefficient tags along. T to the minus 3, right? You bring the exponent down front, and then you subtract 1 from the original exponent. Of course, we don't like to leave negative exponents. So to sort of clean this up, negative 24 over t to the 4th should be the correct answer. Number 13 looks even a little messier. First of all, we hardly ever do any math problems with radical. So I'm going to change this to square root. I can change this to a power of 1/2, but then also have to move it to the top. So let me do both those at the same time. So I can rewrite this original function as 7 times x plus 1, the quantity raised to negative 1/2 power. Now this is a case where to take the derivative, normally we would use what's called the chain rule, although it's going to be pretty simple in this case. If I take the derivative, the 7 is a coefficient. Chain rule says you got the parentheses, you go ahead, bring the exponent in front, copy down the whole parenthesis, you subtract 1 from the original exponent, so negative 1/2 minus 1 is negative 3/2, and then you multiply by the derivative of what is inside your parentheses. Well, the derivative of x plus 1 is just 1. So if I try and clean all this up, this whole thing is going to be negative. Looks like 7 on the top, 2 on the bottom, and x plus 1 raised to the 3/2 power. And that is correct right there. See what's next. All right, here's a question on continuity, which can be a little confusing. I talked about this a couple of problems ago. Here's the check for continuity at a point. So they're saying, is f continuous at x equals 2? Is x differentiable? So the first part is continuity. So what you have to do is you take your function and you figure out what the function equals when x is 2, so that's f of 2. And then you take the function and you see what the function equals with the limit as x approaches 2. And you compare these two numbers. And if they're the same number, then it's continuous. If the numbers are different, then it's not continuous. So this is a piecewise function. It's pretty tricky. So f of 2, we have to see which one of these functions we use for f of 2. We use the top one because it says this is the function you use when x is less than or equal to 2. So f of 2, we put in 2 for x, 2 squared is 4 plus 5. Looks like f of 2 is 9. Now the limit is a little bit of a pain because we're looking at the limit as x approaches 2. So we have to look at the limit as we come from the left side and the right side, because the place we're looking is the transition. So as we look at this from the left side, we look at this equation, we plug in a 2 for x and it's 9. Now, if we come from the right side, we plug in 2 for x and it's also 9. So the good thing is we do have a limit. The limit as x approaches 2 of the function does equal 9. So now we say, is the function itself at x equal 2, and is the limit as x equal to the function equal to 9? Yes. So actually, is it continuous? Yes, it is. Now, is it differentiable? Normally, it's not, because we use the word for differentiable. You have to have a smooth function. Almost always with a piecewise function, you're going to have some kind of a, well, that's not a very good picture, but normally at this point here, there's some kind of a point, a corner, or something going on. So my guess is that for this piecewise function, it's not differentiable. Okay, now we're going back to doing some derivatives. So how about y equals 18 times square root of x? I'm going to take the derivative of that. First step is to get rid of the radical and change square root of x to x to the 1/2. The derivative, 18, is a coefficient. You bring the 1/2 down front, and then you subtract 1 from the original exponent, which leaves it negative 1/2. So 18 times 1/2 is 9. This x to the negative 1/2 goes on the bottom, and maybe just for fun, I'll go back and call it 9 over square root of x. And that is correct. Pretty straightforward here. First step is, if we want to use the power rule, we have to get the variable up in the numerator, up in the top. So 80 over x to the 8th becomes 80 times x to the minus 8th. So now, I want to take the derivative. 80 is a coefficient, so you bring the minus 8 down front. You subtract 1. 80 times negative 8, I think it's negative 640. If I get rid of my negative exponent, next number is 640 over x to the 9th. Last one on this page. I got 2 terms in here. Of course, when you take the derivative, you just take the derivative one term at a time. But I've got to rewrite these because this is the 7th root of x. I'm going to write that as x to the 1/7. And this is 7 over x. So 7x to the minus 1. So now, I could say y equals that. So now divide the x. Here, x to the 1/7, the 1/7 goes in front. When you subtract 1 from 1/7, you get minus 6/7. Minus 7. Derivative of x minus 1 is x to the minus 1. and we subtract 1, you get x to the minus 2. Now, if I get rid of my negative exponents, this is 1 over 7 x to the 6/7. This minus and this minus cancel out. And 7 over x squared. So that is correct. So hopefully most of these derivatives not too hard. So here's one. We've actually done a problem like this. Find the equation for the line that is tangent to the curve at y equals x cubed minus 9x at the point 3, 0. So we're looking at a specific point on this function, and we're trying to figure out the equation for the tangent line. Once again, we're going to use that point slope equation. Y minus y1 equals mx minus x1. So our point is 3, 0, x1, y1. We're going to figure out what the slope is of this function at that point, and then we can start plugging stuff in. So first thing we have to do is take the derivative of our function. So y equals x cubed minus 9x. If I take the derivative, 3x squared minus 9. Now what I need to do is, so this is really my slope, but I need to get the slope at this point. So I'm going to plug in 3. I could write it like this. The derivative when x is equal to 3. So you plug in 3 for x. So that would 9 minus 9. 27 minus 9. So it looks like the slope of the tangent line at this point is 18. So now y of my point is 0. My slope at that point is 18. X at that point is 3. So if I multiply out the parentheses, y equals 18x minus 54. And that is correct. Now 19.1 is an interesting problem. For the function, find the points on the graph where the tangent line is horizontal. The whole key to that is a horizontal tangent line happens when the slope is 0, but the first derivative is the same thing as the slope. So it's the same thing as saying when the first derivative is 0. Here's our function, and they want to find the points and where the tangent line is going to be horizontal. So all we're going to do is we're going to find the derivative of this function and set it equal to 0 and solve for x. And those will be the points where the tangent line is horizontal. So dy dx is 2x. So this is the derivative, or you can think of this as the slope of the function. Of course, it depends upon x. What I want to know is at what values of x is this derivative equal to 0, which means I'm going to just set it equal to 0 and then solve for x. So 2x equals 0. Divide both sides by 2. And you get x equals 0. So this is the point at which the tangent line is horizontal. but they want both the x and the y. So I put in 0 for x. If I want to get y, I plug in 0 into my original equation. I plug in 0 for x here. You get 0 squared minus 3. Looks like this is the point where the tangent line is horizontal. The whole key to this kind of problem is you set the first derivative equal to 0. So here's the first derivative, 2x. Set that equal to 0 and solve for x. And then you've got the answer. Number 20 is similar, but they say for the function, find the points in the graph where the tangent line is slope of 5. Horizontal slope up here meant slope of 0. Same kind of problem here, except now we want to set the slope equal to 5. So we're going to go and take the derivative of this function. So it's going to be negative 0.025 times 2 x to the first plus 7. So this is the first derivative, but we want to know the points at where this first derivative equals 5. So this, in a sense, is like the slope. We want to know where does the slope equal 5. So you have, if you multiply this 0.05x plus 7 equals 5. And we need to solve this thing for x. I subtract 7 from both sides, divide both sides by negative 0.05. I'm not going to trust myself to do this. So if it's looking for a point, an ordered pair, x is 40. How do I find y? I plug 40 back in to this original equation. So 40 squared times 0.025 negative 40 plus 7x. If x is 40, 7 times 40 is 280. Looks like it's 240. So 40, x is 40, y is 240. That's the point. All right. Now we're getting to some story problems. So this is where the fun begins. All right, let me take a quick drink for my throat and then we'll dive into this. So the story problem. In T years, so we're looking at something that's changing every year. The population of a certain city grows from 100,000 to a size P given this equation. So basically giving you an equation, what this equation is telling you is if you plug in a number of years for T, this equation, you can do a calculation and it'll tell you how much the population has grown. Sometimes they call this a model. It may not be exactly perfect, but it's very close. So if someone wants to know how much is the population going to grow in 5 years, you plug a 5 in for T, do the calculation, tells you how much it's going to grow. Of course, we're also going to look at some calculus kinds of things. The growth rate is another word for derivative. So what they're going to do now is take this equation and they're going to take the derivative. So we have P of T equals 100,000 plus 6,000 T squared. If I want to get the derivative dP dt, well, this first term is a constant, so the derivative is 0. This one is 6,000 as a coefficient. The 2 comes down front, and you subtract 1 from the original, and you get 6,000 times 2 times T. So that's the growth rate. So this tells you how it's growing. It's a positive number, so as T gets larger and larger, the growth rate also is growing. So this city is really growing. So that's part A. Check my answer. So I'll mess up. Yep. So part B says find the population after 20 years. So that goes back to the original equation. Population after 20 years means you plug in 20 for T and then do the math. Because the key thing is you plug in 20 for T here and you get 400. So you got 400 times 6,000 plus 100,000. I think this is like 2,500,000. 1, 2, 3. 1, 2, 3. Yep. So after 20 years, this is how many people they predict you're going to have. Find the growth rate T equals 20. So the population is P of 20. The growth rate's another word for slope. So really what they want, the growth rate when T is 20 is the first derivative. You plug in T equals 20. So here's the equation for the first derivative, 12,000 T. Now this should be, do this in my head, 240,000. Now the units here, this is a rate. That's how things are changing. 240,000 people per year. So when they get to part D, you have this answer, they're saying in words, what does this mean? This is a growth rate, which means it's positive, it's increasing. So the growth rate tells the difference between the rate of growth at the beginning of T and T20. No, it doesn't really, that's not really true. The growth rate tells the rate at which a population is growing at time. That's not really true. The growth rate tells the rate at which the population is growing at time T. No, the growth rate tells the average growth from time T to 20. I think that's correct, D. It's the average rate of change. Oh, did I mess up? Good thing I have the key. They said the answer is B. The growth rate tells the rate at which the population is growing at time T20. Oh, yeah. This is the average. Sorry, I wasn't paying attention. We were asking that specifically at the 20th year, what's going on. D is like the average rate over the whole time, all 20 years. Sorry about that. Now it looks like we're gonna do some more taking derivatives. Probably we learned our new rules like product rule, quotient rule. Now here's an example where in math, there's oftentimes more than one way to do something. And normally it doesn't really matter which way you choose as long as you can get the correct answer. I usually try and choose what I think is the simplest way to do it. Just as a rule, that's usually my philosophy. Let me show you the two ways I can see to do this. If you think of this as like two functions, you've got all the stuff inside the parentheses and this up front. You can see this is pretty clearly, you could use the product rule, right, to take the derivative. But another thing you could do is you could just multiply out this parenthesis, and then you would have four terms, and then you would just apply more or less the power rule. And honestly, if I had to do it, I would probably multiply out the parentheses because I think that doesn't look too bad. Maybe just for fun, maybe I do it both ways. I should get the same answer, so it doesn't take too long. So if I decide to multiply it out, 3x minus 3 times x to the fourth is going to be 3x. 3x minus 3x to the third is going to be minus 9. 3x minus 3 plus 11x is going to be 33x to the minus 2. And then 3x to the minus 3 times negative is like negative 24. Now, if I take if this is equal to the function, I take the derivative. It's going to be 3 minus 66 over x cubed. So negative 24 times negative 3, I think it's going to be plus 72 over x to the fourth. There's a good chance I might have messed up, but maybe not. Actually, that's correct. But the other way, if I did a product rule, I always take the first times the derivative of the second one. Derivative of the second one would be 4x cubed minus 9x squared plus 11. So the first times derivative of the second plus the second minus 3x cubed plus 11x minus 8. The second times derivative of the first, which is going to be minus 9x to the minus fourth. Wow. Then I have to multiply out the two parentheses and then combine like terms. I think the first row is definitely easier. In fact, I'm not going to finish this because it's just a bunch of algebra. Interesting. Now this one, I sort of face the same dilemma. Two functions, if I would take the derivative, I could do the product rule, or I could try and multiply them out. In this case, let's not multiply them out. Let's do the product rule, and we'll see what happens. See if how messy it is. So the first times the derivative of the second, derivative of t squared minus 8 is just 2t plus the second, t squared minus 8 times the derivative of the first, derivative of 8t is just 8. Derivative of 7 over t is minus 7 over t squared. Now that's a little messy because basically now I need to multiply them out and combine like terms. So 8t times 2t is 16t squared. 7 over t times 2t is 14. Right, the t's cancel out, 7 times 2. Now this I have to FOIL, which is crazy. T squared times 8 is 8t squared. T squared times negative 7 over t squared is just negative 7. Negative 8 times 8 is negative 64 plus 56 over t squared. Hope I'm making mistakes. Now if I want to combine like terms, I've got two t squared terms. 16 plus 8. I got a bunch of numbers here. 14 minus 7 is 7. Minus 64. I'm going to occasionally check this answer, make sure I'm not off. So far, it looks good. And then this is just all by itself. Plus 56 over t squared. Pretty messy, but actually that's correct. So that's good. This one, it's like a classic case of the chain rule, right? You've got parentheses, stuff inside parentheses, raised to an exponent. So if you want to take the derivative, exponent comes down, you just copy what's inside the parentheses. And then you subtract 1 from the exponent. And then don't forget that you have to multiply by the derivative of what's inside the parentheses. In this case, it's just 8x. So now if you clean things up, so 8x times negative 13 looks like negative 104x over 4x squared minus 14. Now, let me see if that looks reasonable. Negative 104x, 4x squared minus 14, all raised to the 14th power. Yep. Thankfully, they're making mistakes on that. So now, let's do a few more of these. Take another break. 25. Another equation where we're asked to take the derivative. So I see here I've got a radical. Almost always in math, I'm going to get rid of the radical. So let's write this as for the derivative, I have to use product rule, right? This times this. So the first times derivative of the second one. So the derivative that's parentheses is you bring the 1/2 down front, copy your parenthesis, subtract 1 from the exponent, and you multiply by the derivative of what's inside the parentheses. That's the first half of the product rule. The first times derivative of the second plus the second times derivative of the first, which is just 2x. Now with some of these problems, the key is trying to just simplify things. So this is number 25. So 1/2 times the 2, those sort of cancel out. So what you really have is x squared over two x minus 3 to the 1/2. And here, two x times 2x minus 3 to the 1/2. Now what they do is they sort of, when I look at the answer, it looks like they try and I'm not sure what they do. I'm not gonna spend a lot of time. I want to make sure I didn't make any mistakes here. So product rule, first times derivative of the second plus the second derivative of the first. I'm not going to spend time trying to see how they simplify this thing. I think what they do is they try and get a common denominator. Say multiply this thing by 2x minus 3 to the 1/2. So now they have a common denominator. They have x squared plus 2x minus 3 over 2x minus 3 to the 1/2. Then they probably multiply this out. Or actually, I think what they do is they probably factor out the x. And they have x times x plus 2, 2x minus 3. This is getting sort of messy. Two x plus 2x minus 3 is 4x minus 6. So it's 5x minus 6. I'm going to start doing a lot of this in my head just to sort of be crazy. So this is pretty messy. And that's actually the answer that they have. Wouldn't worry about that too much. All right. Here's this dy, du, dx. We got these extra variable u. So actually, this is too hard. You sort of follow along here. Dy, du. So go get your equation for y. Take the derivative with respect to u. So here's y. So it's just going to be 54u to the 53rd. And then du dx is this one here. So if we take derivative with respect to x, you get 20x to the 4th minus 6x. But what's tricky is the dy dx, because what dy dx is really, it's dy du times du dx. And when you get an answer, you can't have any u's in it. What do I mean by that? So I'm going to go ahead and here's dy dx. Need to multiply that by du dx, but I've got this u here. So before I multiply it, I want to replace the u with this whole thing right here, which is sort of messy. So let me write it this way. Dy du is 54u to the 53rd, but in place of u, I'm going to put this right here. So it's 54 times 4x to the 5th minus 3x squared. So that's dy du times du dx, 20x to the 4th minus 6x. So then you got to FOIL these parentheses out and combine everything. I'm just going to go ahead and give you the answer. I don't want to take the time. Oh, I forgot. This is to the 53rd. Whoops. So actually, you don't FOIL these out. So this is pretty much the answer. It's pretty messy. 54 times 4x to the 5th minus 3x squared, the whole quantity raised to the 53rd power, 20x to the 4th minus 6x. So actually, that's pretty much done anyways. 27. All right, this one's pretty straightforward. This means the 5th derivative. So you take your original function or equation, and you have to take the derivative 5 consecutive times. So in other words, dy dx 6 comes down, so it's 18x to the 5th minus 6x squared plus 7. Now, second derivative means you take the first derivative and just take the derivative again. 50, it's 90. And the x to the 4th minus 12x, that's 0. You just keep going. (360x cubed minus 12). You just keep going. 360 times 3 is what? 9,080 x squared. And if I didn't mess up, finally the 5th derivative is 2,160x. What chances that's correct? Number 27. Actually, I was pretty careful that it was the correct answer. All right, so higher order derivatives, just keep taking derivatives over and over again. Not too difficult. All right, let's do these last two, and then we'll take a break. So one of the most common kinds of problems is the idea of velocity, acceleration, and location, whatever it's called. So here, I guess it's called displacement. S of t equals 5t squared plus 15t, where S of t is in feet and t is in seconds. So when you have S or displacement, the rule is the velocity is the derivative of S. So the velocity is the first derivative of this displacement. So that's going to be 10t plus 15. So that should be the first answer. I won't get into all the physics part of this. You just need to know that the velocity is the derivative of the displacement. And then the acceleration is a derivative of the velocity. So if this is the velocity, the acceleration is just going to be 10, right? If you take a derivative of this. When 10 equals 2 seconds, the velocity is, well, here's the equation for the velocity. So you plug in 2 for t, you get 20 plus 15. And I might want units here, feet per second. When t equals 2, the acceleration, well, here's the equation of acceleration, actually doesn't change. It's not based upon the time, it's just always 10. Acceleration is feet squared per second. Oh, sorry. Feet per second squared. Oh, and here they have the units. So there's that. And then the last one we do now is another sort of, they give you an equation for the displacement. Object is dropped off a certain Earth-like planet. The distance it falls in t seconds, assuming that the air resistance is negligible is directed by. Sounds like they're in outer space. They dropped something, and this is the distance. I've been calling it displacement, but I guess the better word is distance. Displacement is more like what they use in physics, but distances, yeah, I should have been using the word distance. The distance equals 12t squared. Suppose that a medic's reflex hammer is dropped from a hovering helicopter. Oh, so this is actually on the Earth, but it says Earth-like planet. Find how far the hammer falls in 5 seconds. Well, this is location or distance. So you plug in 5 for t. Twelve times 5 squared, 25 times 12, I believe is 300. So it falls 300 feet in 5 seconds. The hammer is traveling how many feet per second? 5 seconds. So it's like the velocity when the time is 5. Of course, the velocity is the derivative of the distance. So velocity is 24t. So you plug in 5. Got 120 feet per second. And acceleration, which is just derivative of the velocity, it's 24. Doesn't actually change. And there you go. Yeah, so earlier I called it displacement. Normally they call it S distance. Sorry about that. So the key is take derivative of the distance to get the velocity. Take the derivative of velocity to get the acceleration. So not too hard. All right, now is a good stopping point because the next thing we're going to do is start looking at some derivatives of exponential functions. So we'll stop this one for now and we'll pick it up with the next video.